Hi everyone, this is your air pollution part 3 notes. In these notes we'll be discussing acid rain, how it's formed, and what the effects of acid rain and acid deposition are on the environment and on the health of organisms. So let's go ahead and start with what acid rain or acid deposition is. Acid deposition is when you have either wet acids like acid rain or dry acid, so just acid in a dry form as opposed to a wet rain form, fall from the atmosphere. And this acid deposition is caused mainly by coal-burning power plants and by motor vehicle emissions. There can also be natural sources as well. Rain's pH is usually going to be pretty close to neutral, so close to a pH of 7. We have acid rain considered acidic when it is going to be lower than around a pH of 5.6. So at that point, you're talking about between 10 and 20 times more acidic than you would normally have typical rain. Threatening human health and aquatic ecosystems is one of the big side effects of having acid rain occur, especially in high concentrations. You can have irritation of your eyes, irritation of your lungs or skin due to high enough concentrations of acid rain. It can also affect the health of aquatic ecosystems that we'll get into a little bit in just a minute. We can also have forests, for example, literally the leaves of trees being damaged by the acid deposition. And then also what we can most commonly see is human-built structures such as building and statues being damaged. So if you take a look at the picture on the right, you can see that the statue looks a little bit eroded. And the reason that that statue looks like some of the features have kind of been eroded or pockmarked is due to the effects of acid rain over time. The acid effects with the materials such as maybe a marble or limestone that statue is made up of, and that reaction causes it to eat away at the statue's material. So as we mentioned on the previous slide, the way that acid deposition occurs is through chemicals from usually cars or motor vehicles and coal-burning power plants being released into the atmosphere. These chemicals consist of nitrogen oxides, or your NOx chemicals, and sulfur dioxide, or SO2 chemicals that are being released into the atmosphere. When those chemicals are released, when they mix with water in the atmosphere, they go from being a primary pollutant to becoming a secondary pollutant such as nitric acid or sulfuric acid, and those are going to contribute to the acidic nature of acid deposition. So let's take a look at this picture that's over on the left. In this case, you can see that we have some of our sources of the chemicals that are going to create acid deposition, such as a factory, and they're being released into the atmosphere. So you can see these acidic gases, such as sulfur dioxide and nitrogen oxides, are released. Those gases are then going to be carried and dissolved into rainwater. And then once they're dissolved into rainwater, they become the secondary pollutants that cause the either wet or dry acid deposition. Wet acid deposition basically being acid rain. And then that will fall often on nearby communities. So when we see communities downwind, as we're seeing in this picture right here, of coal-burning power plants, they are going to be your communities most affected by acid rain or acid deposition. That acid falling out of the atmosphere is then going to affect the environment. So you can see at the bottom, acid rain kills plant life, pollutes rivers and streams, and erodes stonework. In that case, they're referring to buildings and statuary. You can see in the pictures on the right some of the effects of acid rain as well. So for example, these trees, if you'll notice, a lot of them are having some leaf loss. So the acid has basically damaged the leaves. And if you take a look at the bottom right picture, you can see the statue on the left has a lot more definition than the after picture on the right of the same statue, where acid rain has eroded those features. Again, because as the acid reacts with the materials, such as maybe a limestone or marble that those statues and buildings are made out of, the reaction that occurs causes it to eat away at the definition of that statue. All right, so I mentioned the wet and dry deposition a little bit earlier, so let's go ahead and define those so you can have them added to your notes. So acid deposition, we often just kind of commonly call acid rain, but acid rain does not always have to be rain. It doesn't have to be wet. With acid deposition, that sulfuric acid and nitric acid compounds can actually fall out of the atmosphere as particles instead and be dry deposition. So wet deposition would usually include rain, snow, fog, or cloud vapor that contains these acid chemicals, whereas dry deposition just wouldn't be wet. It wouldn't be in the form of a precipitation. It would just be the particles falling out of the atmosphere. Both of these, though, are capable of acidifying an environment, and we'll talk a little bit more about those effects on the environment in just a minute. One thing to note, though, is that the Clean Air Act in the U.S. did help with reducing acid rain occurrences, And this is because the Clean Air Act helps limit some of these polluting chemicals that are released into the atmosphere. The Clean Air Act does this by legally regulating the amount of chemicals that are allowed to be released by certain locations, so for example a coal-fired power plant, into the atmosphere. Let's go ahead and move on and discuss some of the effects of acid deposition on the environment. You can see in the picture on the right there's another image of a building that has been damaged by acid rain. Again, those pockmarks and kind of eroded areas are due to the acid eating away at that particular material, probably a marble that building is made out of. So this is pretty devastating considering that quite a few of our ancient ruins that we have are made out of materials that would react with acid rain, and it's damaging buildings that have been standing for hundreds or maybe even thousands of years. Some of the effects on the environment can include lowering the pH on lakes and water bodies. So remember that 7 is a neutral pH. pHs above 7 are basic or alkaline, and pHs below 7 are considered acidic. So when we are lowering the pH, we are lowering that number below 7. One of the examples of this is the effect on amphibians, or organisms like frogs, which can only survive in water bodies that have a pH that is around maybe 6.5 to neutral, just a little bit lower than that, so a little bit more acidic, and they will really struggle to survive. They can start to have developmental or reproductive issues. We can also have metals in the environment leach out of the soils and sediments that they are contained within, and if those are released, they can be released into surface water, and certain chemicals such as mercury can be problematic, and they can also be toxic as well. Not only can we have pH lowered in water bodies, but we can see soil acidify as well, which can make it difficult for plants to grow within it. And then we've already discussed the effect on statues, monuments, and buildings, which can all erode due to the exposure of acid. That is because a lot of these buildings contain materials such as marble or limestone, and those materials can include calcium carbonate, which is an alkaline or basic material, and when it reacts with an acidic material, it can cause them to dissolve. We should also understand a little bit more about how soils are affected by acid rain. I mentioned on the last slide that they can acidify. So what can happen with the soil is it can mix in with the acid rain, and we can see them start to become a more acidic pH. Some materials, though, in soils, depending on where the soil is located, can actually help neutralize that acid. So if you have a substance in a soil, usually due to whatever their bedrock is made out of, that is more alkaline, such as limestone, we can see that soil react with the acid and help to neutralize it. So basically you're mixing a base with an acid and helping neutralize the effects of the acid. This can help prevent the acid rain from affecting nearby water bodies or affecting the growth of plants. The problem is, though, that not all soils contain these materials, and so depending on where they are located and what the bedrock material or composition is, the soil may or may not be able to help neutralize some of the effects of that acid. All right, the final thing I'd like to take a look at is some of the locations worldwide that are affected by acid rain. Remember, on the AP exam, they do like to give you maps and have you identify certain areas. So you may want to take a note of a few of these. So if we take a look at the eastern part of the US, there are a number of very large cities located there. Large cities often mean more motor vehicles, more coal-burning power plants, and those are going to contribute to acid rain. If we take a look in the Asian continent, we can see that there are certain parts of China, especially on its more eastern end, that are going to have, again, larger cities. So we see more acid deposition in those locations. And then notice that quite a bit of Europe, where there are a lot of very large cities as well, are affected by acid deposition. Thank you for watching the Air Pollution Part 3 Notes.